A 1982 paper by Hans Rosendahl and Samuel Shaw established a correlation between the maximum sustained surface wind speeds to the minimum sea level pressure in central North Pacific cyclones. Use the following data below to test this result. So first we have the minimum sea level pressure in millibars and the surface wind speed in knots. And so you have to decide which data is going to be your dependent variable, which is going to be your independent variable. So it's not told to you. You can generally just assume that the first data set is your independent variable x, and the second set of data is your dependent variable y. And I would say this is probably accurate here because you can measure the sea level pressure and try to predict what the surface wind speed is going to be based off of that. So yes, so let's take this data and we'll calculate the correlation coefficient rounding to 3 decimal places. So the first thing that we need to do is enter this data into the calculator. So we'll go into the list editor, so press Stat and Edit. If you happen to have any data already in the list, clear that out and start entering your data one value at a time, taking care to check and make sure you've typed it in properly, because it's very difficult to deduce whether a student has done something improperly or just mistyped data when wrong answers show up. Now I'm going to go ahead and pause the video and then finish typing these in just to save you all some time. But as you get to the bottom of the first list, you just arrow over to L2 and you start putting in your wind speeds over there. Okay, so once your data's in, then you're ready to do linear regression. And to do linear regression, we press the Stat key and go over to the Calc menu, come down to the fourth item here, linreg ax plus b. So when we do the linear regression, just press enter. If you don't get a menu like this, that's okay. You just have one of the older model calculators probably. All you need to do is just press second and 1 to get L1 on screen, and then you would hit a comma, and then that's just right above the 7. Then press second and 2 to get L2. Effectively, all this menu is going to do is take the different inputs and separate them by comma on screen automatically. So the functionality is the same. So anyway, if you have the menu here, X list data set to L1, your Y list data should be L2. Make sure frequency list is clear because we don't have any frequencies here. That's not common for this type of problem. And to store the regression equation, we're not going to worry about that. Just leave that blank as well. And then hit calculate, and it will perform the regression. So the correlation coefficient is the value R, which is negative 0.877. And if you didn't happen to see that on screen, then that means your stat diagnostics are not turned on. So in order to turn that on in the calculator, press second and catalog, and then just scroll down until you get to an option that says diagnostic on. And it takes a moment because it's pretty far down, but it's just to the D's, so it's not too bad. But once you get there, just press enter twice, and then the next time you run linear regression, you'll get all the information that you need. Okay, so let's go back to where we were. Next, we need to get the equation of the regression line. So the equation of the regression line comes from these values here, a and b. That's the slope of the regression line and the y-intercept of the regression line. And it says to round to each value to 2 decimal places. So this would be y equals negative 0.93x and 1005.95. Okay. And next we have some new data that's just arrived indicating the minimum sea level pressure for a storm is 977 millibars. Predict the maximum sustained wind in knots. Round your answer to the nearest integer. So we'll just take this line equation that we have and plug the value of x into it, which is 977. And then just calculate from there. So negative 0.93 times 977 plus 1005.95. So that's 97.34. And it did say to round to the nearest integer, so we'll just say 97 knots.